Hello all. In this video, let's talk about the random tensors, how to create zeros tensors, one tensors, and how to multiply zero tensors with the random tensors, and what is the difference between range versus arrange. If you're watching this video for the first time, I'm Rajiv Pujala, and I would recommend you to watch the previous videos as well to understand in-depth deep learning using the PyTorch. So let's go back to our collab, and here, so I have connected to my GPU, so that's the reason you can see all the values over here. So so let's import the torch. If you would like to know how to connect to the GPU, or how to check whether you connected to the CPU or the GPU, so I recommend you to go through my previous videos and watch them. So I'm importing the torch library over here. So let's start creating the random tensors, and then the other values as well. So basically, a random tensor, right? So basically, what is a random tensor? Any tensor which has the random values is equal torch dot rand size is equal to 3 by 4. So I'm going to create a tensor which has 3 rows and 4 columns. So that's the reason I have mentioned size is equal to 3 by 4. Now you can see that we created a tensor with 3 rows and the 4 columns. So if you would like to see to know the dimension, so n dimension, so you can see like how many dimensions are there. There are like two arrays here, so 2 dimensions. Dot shape. Let's see the shape. How many? It's like 3 by 4. We just gave that one, and the size as well. As I said earlier, both are same. And also, if you want to access the first value, zero dot item. So so basically you can see the first value. And now let's see, this is about the random tensors, and let's see how we can create normalized random tensor. What exactly is normalized, right? Interesting. So normalized random tensor, I'm copying this one so that I don't have to type it again and again. So torch dot rand. So what we create? So we created for the rand. For rand is for the random values, and rand n is for the normalization. Size is equal to 3 by 4. Let's see what exactly is this one. So basically, what the normalization does here is that if you look at statistically, so for example, if you have a one value, so let's assume the first value as x. If you take the normal value, for example, here it is like 0.6441, right? For example, let's say that assume that x is equal to 10. X is equal to 10. Now let's do the x standard x mean, which is the average, and x standard deviation, which is the standard deviation. So basically what it does is that x, our value, minus our average value, divided by the standard deviation. This is the normalization. This is how they calculate the normalization of the values, okay, right? So this is the normalized tensor. And now let's see how to okay, so for example, if in case let's go back to the normalized tensor, right? So here, for example, torch dot rand n, which we already seen just now, size is equal to 3 by 4. So print this one. This is good, right? You can see two arrays over here. And what if in case if you want three here, so basically you keep one over here, size, and now you can see that there are like three arrays here. So if you want like a matrix of this like one more time, so you come here, you do like two here, and there you can see. So for now I'm keeping it simple. So 3 by 4, this one 3 by 4. Okay, let's talk about let's take a code. No, let's take a text. So let's talk about zeros tensor. So what is a zero tensor? Basically, if a tensor is filled with all the zeros, it's a zero tensor. So zeros tensor is equal to torch dot zeros of size is equal to, I'm creating a 3 by 4 tensor, print 0 tensor, right? As simple as that. So for example, let's see what's our random tensor. This is also 3 by 4 one, right? So how you can get to know random tensor dot size 3 by 4, 3 by 4, this shape is matching, so let's multiply this one. So how we can, let's multiply. So zeros tensor which has all the zeros, and random tensor which has random values, so obviously it will return all the values with zero values, right? So now let's create ones tensor. What is this one? So basically we're going to create a tensor with all the values filled with 1. So ones tensor is equal to torch dot tensor, no, torch dot ones, right? Size is equal to 3 by 4. So print ones tensor. So you can see all the values are filled with ones. So now I'm planning to going ahead to multiply this ones tensor with the random tensor, right? So you can see this is exactly same as random tensor. Basically anything multiplied by 1 is anything like same thing, right? So this is good. So now let's see zeros like tensor. What exactly is zeros like tensor? So for example, let's assume that we have a tensor t is equal to torch dot rand, a random tensor, size is equal to 4 by 5, right? Print t. So now you have a tensor of 4 by 5, and now if in case if you want to multiply this tensor with all the zeros, basically you have to create one more tensor, and you have to create a tensor with dummy values, like, and there should be like 4 columns and the 4 rows and the 5 columns. Rather than that, we have a concept called zeros tensor, zeros like. So zeros like tensor, so is equal to torch dot zeros like. So what I would like to have t here, because this is the tensor. So I'm telling to the system that there is a tensor. So you create a zeros tensor, and and the shape of this tensor, the zeros tensor, should be as same as as same as the t value, right? See, as easy as that. Zeros like tensor, so you can see all the zeros value here. I mean, if you look at the size of this one, so it's like it's same like 4 by 5 over here. Oh, this is so good. So now let's create ones like tensor, right? So how we can create, we already have the 4t here. So ones like tensor is equal to torch dot ones like, right, into value t. So print this one, all the ones, right? So let's see the size of this one, all ones dot size. So this is as same as 4 by 5, this is as same as the 4 by 5. This is good. So let's talk about arrange. Let's talk about the range first. Range. Okay. So for example, t is equal to toss dot range, starting is equal to 0, end is equal to 1, step is equal to 1. So basically I want to create a tensor with the value starting with 0, ending with the 10, and I wanted this to increment gradually. So by 1 is a by default, whether you mention 1 or not. So basically I wanted the value like 0, 1, 2, 3, and also print t. So if you notice here, the values are like so. Basically, I don't recommend you going forward. Like you use this range. I would like to show you the difference between the range versus arrange. So basically, this toss dot range, it is deprecating. It will be deprecated in the future. So basically, if you use it now, it will work. Maybe in the future, your code may go into error, and then you have to understand like, oh, this is deprecated, right? So you can see the values 0, 1, 2, 3, etc. If in case if you don't want to see this one, let us try this one. I'm not sure whether it will work or not. Input warnings, warnings dot filter warnings, ignore. I don't want to see any values here. Okay, so now let's do this one. Okay, now you can see that the value started with 0 and end with 10. So 0, 1, 2, 3, 4, 5, 6, and everything happened, right? Now let's look at arrange. So same one, torch dot arrange arrange. So I'm giving the same value. Start is equal to 0, um, end is equal to 10, step is equal to 1. So print t. So now let's see. So basically it has created a tensor with values 0 to 9. So basically the difference between the range and arrange is that in the range, so it will create all the values including the end step as well, whereas in the arrange, so it will only create, it will exclude the last value and it will be like last minus 1. For example, if you mention 10 here, it's always like 10 minus 1. But going forward, we have to use the arrange only, so we have to adjust to this concept. That's all a little of about this video. So thank you.